Guys, we're going to do a video lesson today for trigonometry since I'm absent. So the first thing we're going to talk about is what exactly is trigonometry. And we've been talking a lot about triangles and a lot about the angles in triangles and how angles can affect the sides of triangles. So really, trigonometry is a study of all of that. It's a study of how the angles of a triangle are going to affect the sides of a triangle. So really just a triangle kind of study, a study of the measurements of triangles. Now within trigonometry, we have three main ratios that we talk about, the sine, cosine, and tangent functions. And each acute angle of a right triangle has the following trigonometric ratios, these sine, cosine, and tangent functions that exist. The first one we'll talk about is sine, and really all of these functions are their ratios. If you look at the definition of the sine function, it says the ratio of the leg opposite the angle to the hypotenuse. So what we're going to do is we're just going to explore how to find what's known as the sine of angle A. The sine of angle A, when we see opposite and hypotenuse, the first thing we're going to want to do is just identify where angle A is, which is right there, and then identify the side length that is opposite of A, right? The opposite side length of A is going to be straight through our triangle, and it's going to be given right there. So when we talk sine of A, we're just going to write this as a ratio of A over the hypotenuse of the triangle, which is small letter c. For the next one, we're looking for the sine of angle B, and now since we're dealing with a different angle, the sine of B is going to be different than the sine of A, but we're still using the same opposite over hypotenuse idea. So the side opposite of angle B is going to be angle or small side B, so we'll write that out, B, and then the hypotenuse is still C. So again, just right now we're just identifying how the ratios actually work. Cosine is a ratio of the leg adjacent to the angle, and what I mean by adjacent is that it is touching the angle, but it is not the hypotenuse. So if I'm looking at A and I want to find the cosine of A, since A is given by this side length right here, adjacent would be B. This is the adjacent side. We call it the ADJ. It's a weird D, but you'll have to work with me. All right. The adjacent side of A is going to be B, and the hypotenuse is still C. So our cosine of A will be just B over C. And notice that it's the exact same thing as the sine of angle B. Cosine of angle or of side. Cosine of B is the side adjacent to B, which when we look at our triangle here, adjacent would be A, and then the hypotenuse is still C, so we've got A over C. Last function is tangent, and this refers to the ratio of the leg opposite of the angle to the leg adjacent to the angle. So when we look at A, opposite of A is going to be small letter A, and adjacent to A is going to be small letter B, A over B. Okay, notice this does not contain the hypotenuse. Tangent of B is going to be the side opposite of angle B, which is going to be small letter B, and the side length that is adjacent to B, which would be small letter A. Once we start attributing some numbers to this, it makes a little bit more sense. One of the mnemonic devices that we can use to do this or to identify this, you guys need to always remember so, ka, toa. All right. What this means is when we are identifying the sine of an angle, that this so part is going to represent the opposite side over the hypotenuse. The cosine is going to represent the ka of SOHCAHTOA. This is always the adjacent side length over the hypotenuse. And the tangent of the angle is going to represent the opposite side length over the adjacent side length. Okay, SOHCAHTOA. So if I was in reference to angle B and I wanted to find the sine of B, the opposite side of B would be this side right here, opposite side that's completely through the triangle. And then the hypotenuse of the triangle is always the side opposite the 90 degree. So this would be our hypotenuse. So our sine of b would be an opposite side over hypotenuse. The cosine of b would then be the adjacent side length, ADJ, over the hypotenuse, right? And the tangent would be in reference to the opposite side over the adjacent side. All right, let's start looking at some of these ratios and put them into action a little bit. All right, this is example problem number 1. It asks to find the sine of angle A. Well, the first thing I do is always circle the angle. I remember that the sine is going to be representing my opposite side over my hypotenuse. So when I look at angle A, the side that is opposite of A will be 5, and the hypotenuse of that triangle is 13. So this is my trig ratio, 5 to 13 for the sine of A. Cosine of A is going to be the adjacent side over the hypotenuse. Well, adjacent to A would be 12, and the hypotenuse of the triangle is 13. So this is my cosine of A. And the tangent of A is going to be the opposite side, which will be 5, over 13, or excuse me, over 12, which is going to be the adjacent side length to A. All right, now as we change the reference point, or we change the angle, now we're in reference to angle C. So I'm just going to circle angle C and go through the same process. Sine of C is the opposite over the hypotenuse. That is going to be 12 to 13. Cosine of C is going to be the adjacent side over the hypotenuse. That will be 5 over 13. And the tangent of C, remember that's the TOA of SOHCAHTOA, opposite over adjacent. Opposite side would be 12 over adjacent, which is 5. Okay, so just a little practice identifying these ratios. Let's test out another practice example after you guys have finished writing these down. You can pause the film if you need to. Right? Here's another practice problem. Now notice on this one we've got a right triangle where one of the side lengths is missing. Right? And if one of the side lengths is missing, we can always set up our problem, 9 squared plus 12 squared equals c squared, and figure out what c would be. We should start to recognize some of these Pythagorean triples. This is a 9, 12, 15 triangle. So the hypotenuse of that thing is 15. That may be a step that you'll need to take, is just use Pythagorean theorem. Otherwise, we're still identifying those ratios. Okay, first thing, sine of W. First step, identify W. Go through and think about what is the opposite side length of W, which would be 12, over the hypotenuse, which is 15. Remember, that's the SO of SOHCAHTOA. Cosine of W is going to be the adjacent side length, 9, over the hypotenuse, 15. 9 over 15. And the tangent of W is going to be the opposite side, 12, over the adjacent side, which is just 9, 12 over 9. All right, remember that identifying opposite and adjacent is always in reference to what angle you're talking about. For example, when we switch to find the sine of x and find the cosine of x and tangent of x, now we're using a different angle as our reference point. So we're going to use angle x, and now everything kind of switches. When we do the sine of angle x, now the opposite side, or the opposite side length of x, is going to be 9, and the hypotenuse will be 15, 9 over 15. Cosine of x is going to be the adjacent side, 12 over 15, and then the tangent of x is going to be the opposite side, 9, over the adjacent side, 12. Getting used to saying hypotenuse. All right, now you can try this on your own if you'd like for number 3. Test it out, see if you can find all the missing, or first of all, find the missing side length and then write out what the ratios would be. Give you a hint, here's your missing side length, should be 30. Pause the film if you need to and then go through seeing if you can identify those trig ratios. Now this is working a little bit off of your script, but the next thing that we're going to practice with is actually what it means to type in the tangent of a 45 and what that represents. all right? Now, the tangent function is meant to represent a ratio of the side that is opposite to the side that is the adjacent, all right? Now, we learned about 45, 45, 90 triangles and the fact that these two side lengths will be the exact same thing. This side length and this side length are the exact same. So if the tangent function is meant to show us a ratio of this opposite side to this adjacent side, then when you type in tangent of 45, your keystrokes, or the way that you'll do this, is identify the tangent, which is going to be right here, hit that button, type in 45, and it should give you the number 1. Okay? If it does not give you 1, you may be in radian mode on your calculator and you need to switch it to degrees mode. All right? But the tangent of a 45 is always 1 because the opposite side and the adjacent side are always the exact same number. All right? We learned that with our special right triangles. Okay, so we're just going to practice. This again is not on your worksheet, but we'll just practice actually doing this. And traditionally, I have you guys round to the nearest hundredth. All right? So a sine of a 30-degree angle. When you type in sine 30, sine and then 30 into your calculators, you're going to get the number 1 over 2. All right? 1 over 2 will be the sine of a 30. And we've learned that in a 30, 60, 90 triangle, that this side is x and the hypotenuse is always 2x, which means we're writing this out as a ratio of the side that is opposite over the hypotenuse, which is why the sine of a 30 is 1 over 2. All right. Now, we're not always dealing with special right triangles, so you can find the cosine and the sine and the tangent of a 50-degree angle, and it's going to be a different value. All right. If you guys could all type into your calculators, if you have them, cosine and 50, you're going to get the number 0.64278, and then a whole bunch of other numbers. All right. What this means when we type this in, 0.642, let's say, or let's say 0.643. All right. What this is representing is a ratio of the adjacent side length over the hypotenuse. All right. It is saying that for each triangle, if this side length was 0.643, that this side length would be 1. Okay. It's a ratio of the adjacent side over the hypotenuse. Now, the reason why this is beneficial is because eventually we're going to have to solve some problems or find some missing side length with these trig ratios. And there's a kind of a step-by-step process I'd like you guys to follow. All right. First thing that you'll do is identify what side length do you know and what side length are you trying to solve for. Okay, this is going to help to identify what function we're going to actually use to solve it. What function? All right, with this given triangle, we know the side length that is known as the hypotenuse. All right, and we are trying to solve for the side length that is opposite. All right, which tells us that the function, if we know the hypotenuse and we're trying to solve for the opposite side length, that the function we'll use is going to be either the sine, or the so, the ka, or the toa. Well, the one that contains opposite and hypotenuse is going to be the sine function. All right? So here's our process. The first thing we do is we take the sine of that angle, the sine of a 28-degree angle, and we punch it into our calculator. All right? Sine of a 28-degree angle is going to give us a certain number, and what we'll do is try and round that number to the nearest hundredth of a degree, or hundredth of a place value point. So sine of 28, let's have you guys all punch that into your calculator, and it should get you 0.47 approximately if we round it. All right, so if we go 0.47, what I always advise you guys doing is put that over 1, and we're going to set that equal to the opposite side over the hypotenuse. All right, equals opposite, which in this case is x, over hypotenuse, which is 19. All right, then this looks like a proportion to me, okay, which is what it really is. It's a ratio of opposite over hypotenuse, opposite over hypotenuse. All right, and at that point, we just play baseball, kind of cross multiply and divide, and we solve the proportion. All right, we multiply here, cross multiply, 19 times 0.47, and then we divide by 1, which is just going to leave it the same thing. All right? We do 0.47 times 19, and then divided by 1, we'll get our answer. Which will be about 84.93. That's not right. That's 4.7. 0.47 times 19. It's always good to estimate first, then you don't make mistakes. 8.93. Okay? Which tells us that that x value would be 8.93 units. All right, let's try another example. That was example problem number 1. Make sure that you get these copied down. Example problem number 2. Okay, again, identify your know and your solve. You're trying to identify what function you're going to use. Okay, so in this case, given that angle, given that 41-degree angle, we know the side that is adjacent to the angle. And we're trying to solve for the side that is opposite. So if we look at our SOHCAHTOA, that means that we're using a tangent function, right? Again, we know adjacent, trying to solve for the opposite, that means we're using a tangent function. All right, so next comes our proportion. We say, all right, if I'm using the tangent of a 41-degree angle is equal to the opposite side, which is going to be x, over the adjacent side, which is 32. Tangent of 41 is equal to 0.869, so we're going to round that to 0.87. Remember, my advice is to always put that over 1 and then set it equal to our x over 32, because then we truly see this how it is, which is a proportion. All right, 0.87 over 1. Then we'll take that 0.87, multiply by 32, divide by 1, which keeps it the same number, and we get 27.84. All right, which is going to be the value of x. Which seems like a reasonable amount. If you get something that seems unreasonable, you may want to rethink your options or maybe change something. Okay, so that was solving using a tangent function. Try another example, number 3. If you guys would like to, you can pause the video and see if you can figure this one out on your own. Otherwise, I'm just going to get rolling with it. So, identify your angle, 21. Okay, we know the hypotenuse. We're trying to solve for the adjacent side length. So this means we're using a cosine function. So I'm going to do the cosine of a 21-degree angle is equal to the adjacent over the hypotenuse is equal to x over 26. Now in each of these examples, the x has always been on top, but that's not always the case, just depends on what you're trying to solve for. Cosine of a 21-degree angle is going to get us 0.93 when we actually simplify it. So this is 0.93 rounded. Now the more that we round, the less accurate we are, but I'm okay with you guys getting it to the nearest hundredth. Remember, we put this over 1, set it equal to x over 26. Play baseball, 0.93 times 26. We get you 24.18. X equals 24.18. Which seems like a reasonable amount. It's less than our hypotenuse. If we were to make an estimate, we would see the adjacent side being probably relatively close to the hypotenuse. So that seems like an amount that would be reasonable. Couple more examples. Let's see if we can find one. We're going to skip number 4. Yes, we're going to try number 5 here. So this one's just slightly different, but the process doesn't change. Okay, identify your angle first. This is the opposite side length. we are trying to solve now for the hypotenuse. Okay, opposite and hypotenuse equals out to being a sine function. That's the SO of SOHCAHTOA. So we'll do the sine of our angle, sine of 33, is set equal to the opposite, which is 15, over the hypotenuse, which is x. Sine of 33 equals 15 over x. When we do sine of 53 and punch that into your calculator, the rounded form of that number would be 0.54. Okay, remember that this is a ratio, so we're putting that over 1 and setting it equal to 15 over x. At this juncture, this is a little bit different because before we just multiplied the 0.54 times 15, we got our answer. In this case, we actually need to stay true to our proportional understanding. We cross multiply 15 times 1, but then we need to actually divide by 0.54 to solve for x. Okay, when you divide by something that is in between 0 and 1, you're going to get a number that's larger than what you're dividing. Okay, so this is 15 divided by 0.54, and we'll get 27.8, we'll call it, right? X should equal 27.8. And it does make sense because our hypotenuse needs to be the longest side, 27.8. If we had just simply multiplied 15 times 0.4, we would get something around 7. And that can't possibly be true because the hypotenuse must be the largest side. So this is why we really need to be careful with how we set these up. Now, the last example we'll give is a real-world example. And remember that anytime you get a real-world example, the most important thing is that we model that expression or we model that situation with a picture. All right, so Jake is leaning a 12-foot ladder against his house. The angle formed by the ladder and the ground is 68 degrees. How far from the base of the house did he place the ladder? All right, so a lot of times we'll just have a simple triangle. Here's going to be my house. My ladder will be represented like this. It is saying that it is a 12-foot ladder. The ground is here. We'll use green to represent grass. And the measurement of this angle, it does appear, should be 68 degrees. All right, and the question is, how far from the base of the house did he place the ladder? So we're just going to call that x. Okay, so we're going to solve this problem using that trig idea. Okay, in this example, we know the hypotenuse. We're trying to solve for the adjacent side length. Okay, adjacent means it's touching the angle of reference, and it's not the hypotenuse. So adjacent hypotenuse, that means we're using cosine. So we use cosine of a 68-degree angle and set it equal to the adjacent x over the hypotenuse 12. Cosine of 68 will get us the number 0.37 if it's rounded. 0.37 over 1 is equal to x over 12. We cross multiply 0.37 times 12, divide by 1, and we get the number 4.44. 4.44, and that should be in feet. Okay, so the biggest thing with the word problems, again, just like we've always stated, is that we need to, number one, draw a picture and make sure that that picture would make sense. 4.44 feet seems like a reasonable amount of distance away from a house for a 12-foot ladder. We're probably good to go. All right. So this concludes the lesson. Make sure that you copy down any examples and rewatch this if you need to. Hopefully we were clear with the ideas, and we will talk to you later.